talked about the reality and the challenges in the data recovery industry related to this technology. And I can share with you that this industry is alive with energy and growth.
Just check in and make sure everybody's seeing the correct slide.
Let's back up for a second, folks. Hold on just a moment. Okay. Okay, looks like we're seeing that now appropriately. Okay, now we're seeing the screens okay. In addition, just got back yesterday from VMworld. For those of you who are familiar, VMware, a company of EMC storage, is the leader in the virtualized world or virtualization world. And that's another trade show going on in San Francisco right now. What a lot of buzz, I should say, about the particular industry there. Nothing but talk about virtualization and the cloud. Many new companies have been spawned from the growth of VMware themselves, and there are many new companies both in hardware, software, and services that are all providing services to the cloud. But the biggest and most recent news, unless you have turned off the internet for the last 2 weeks, you are probably already familiar with Matt Honan of Wired Magazine and the story which broke about 2 weeks ago about an unfortunate situation with Amazon, Twitter, Gmail, Apple, and himself. Matt is a senior writer with Wired.com, Longshot Magazine co-founder, well-known technologist and media figure, and unfortunately a victim to data loss and a hack. So Matt had all of his iOS devices linked to the cloud, iCloud in this case. He was using, and this is public information you can read all about on Wired.com. Just type Wired and DriveSavers into your browser, you'll find these articles. He was using a 1Password app to manage his passwords. He was a heavy tweeter on Twitter. He was a Gmail user. He shopped at Amazon. Sounds like many of us, doesn't it? In fact, it sounds a lot like me. But I hope that I have all the proper protections in place. Unfortunately for Matt, he didn't. To quote him, "In the space of 1 hour, my entire digital life was destroyed. First, my Google account was taken over, then deleted. Next, my Twitter account was compromised and used as a platform to broadcast racist and homophobic messages. And worst of all, my Apple ID for iCloud was broken into, and my hackers used it to remotely erase all of the data on my iPhone, iPad, and MacBook." End quote. A perfect example of why we are talking about this today. This is someone in the know, in the industry, utilizing the cloud, using many services, and in one fell swoop became victim to not only data loss, but hacking of his information. It's a great story to bring to you today. We're very happy to have assisted in this case, and I'd like to dig a little bit deeper into it for just a moment so you can understand more about what we did. This is special because this was a solid-state drive as well in cloud space. So what really occurred was a remote wipe of his iCloud iOS devices, as he stated in that article. It was data loss from a malicious, socially engineered attack. The iOS devices themselves, the iPhone and the iPad, in fact, were not recoverable. They are using fairly heavy encryption by default by Apple, and they were securely wiped, and they were unrecoverable. However, the MacBook Air, which was a last year's design utilizing a Samsung solid-state drive internally, did come into our laboratory for recovery after this unfortunate event occurred. We were very kind of happy to get this thing in the lab because we wanted to see what challenges were in front of us, and it turns out they were fairly grand. If you look at the list there, you can see some of the things we ran into that you don't see in a normal data recovery scenario that led us finally to get through this pile of flaming hoops and get to the data on the other side. But the secure remote hack actually overwrote more than 25% of his data at a physical layer. The particular SSD had a proprietary MSATA interface, and now Apple has a new SSD with yet another new interface in the mid-2012 unit. File Vault 2 encryption was enabled on the drive, and a new operating system was installed after the hack. Garbage collection and trim, if you've heard me talk about SSD before, you know those are considerations where we have to deal with in the data recovery. So we had to go down to the physical layer, past the directory tree, and start recovering data based on metadata since the file system was gone on this device. In addition, we had to utilize security during data recovery like we do for every one of our customers, but on special enhanced requests from Mr. Honan in this particular case, while we were processing and recovering his data. And ultimately, the great news is that at the end of the data recovery, once it was completed and we were successful in recovering 75% of the information on the device and everything that he needed, that data was delivered to him on an encrypted backup device to make sure that all of his data was protected moving forward. This particular image appeared in that Wired article, and the photo credit goes, I believe, to Matt himself. And this is one of the photos that was recovered by DriveSavers. It's a photo of the author and his daughter shortly after her birth, and this photo existed only on the drive that we recovered it. I'm sure you can imagine what it was like if this was your photo or your child. When Matt saw these photos, he said, quote, "I almost cried." This is why we do data recovery. So let's get to the meat of the matter here and talk about what you want to learn about today and why that story was very relative moving forward. Let's define the cloud. Cloud computing is really the use of computing resources, hardware and software, that are delivered as a service over a network, typically the internet, but not necessarily so. In utilizing cloud services, a user gives up local management, control, and security of their valuable data in exchange for a lower total cost of ownership and the ability for someone else to manage their information for them. And the name cloud is really a leftover. It comes from the cloud-based shape used in old networking diagrams. For anybody who took a traditional networking class, I'm sure you remember diagrams that looked like this when we used to just call it the network. Then it was a wide area network, and then we defined the cloud. That's kind of the origin, the genesis of the name, and probably a very familiar diagram to many of you. This one representative of current public and private cloud computing platforms. But most relative in the cloud computing space, of which there are many services available, is the service of storage as a service. I don't know if you've seen these acronyms yet, but STAAS is storage as a service. SaaS is software as a service. These are new acronyms coined with the birth of the cloud. But the reason we care about this is we live in the data storage world. So we'll talk specifically about storage as a service as a function of the cloud. This is the concept where a service provider rents space in their cloud on a subscription basis to you, the user. It can be more cost effective than running it yourself, depending on your economies of scale. It is often used as one element of an offsite backup solution, if not part of a full managed platform. And there are many, many services available. You can think of some of the common ones that you hear every day out there, like Amazon S3, Carbonite, CrashPlan, iCloud, Mozy. There is a very, very long and exhausting list to all these companies that are providing storage in the cloud as a service. So that's the public cloud. Let's talk about the private cloud for a moment. Private cloud is cloud infrastructure operated for a single entity or single organization, whether managed internally or externally by a third-party hosted company. There are consumer through enterprise solutions available in private cloud. Hosting a private cloud can require a significant level of investment and engagement to support a full business environment if you're going all to the cloud. And responsibility for hardware and software management may fall on the user or on the third party, and especially security issues that must be addressed in order to avoid serious vulnerabilities or potential breaches. Remember, the trade-off of using the cloud, or one of the trade-offs, is that you give up some control. That's not necessarily a bad thing. It's just something to be aware of as a function of the definition of the private cloud. But let's take it one step further. And I don't know if you're familiar with this term yet, but you surely will be soon, because the industry is using the heck out of it. It's now the personal cloud. The personal cloud is pretty easy to visually describe to you. If you imagine that NAS or RAID box sitting on a desk at home with 2, 4, or 8 drives in it with all your valuable stuff on it, well, not only do you host it in your house now, you can host it outside of your house via a secured connection over your internet connection out to the internet. This is to access remotely all of the data on your home network or your business via small NAS or RAID device. Here you are really weighing the options of your data security versus data accessibility. We all want to share photos of our kids, right? We want to show them to the relatives, and we like to show them the whole library, right? But remember, any data you put out there via a personal cloud on which you host the data is your responsibility for security and your responsibility for maintenance of that unit. If it fails, your cloud goes down just like any other storage device does. Everybody's jumping in the game here. Companies like Buffalo Technology, Synology, Western Digital, Data Robotics, iOmega, everybody's making a personal cloud device now and marketing it quite a bit. So that kind of defines for you the public cloud versus the private cloud versus the personal cloud, all of which are using storage of some sort, some of which are wholly managed and some of which you need to manage partly on your own. So now let's talk about cloud reliability for a moment. Well, the cloud is not magic. It lives on hard disks too. It might be easier to forget about the cloud because it's not something you have to look at sitting in a closet in your office, but nonetheless it sits in a much larger closet in a very large data center somewhere else where you can't see it, touch it, nor control it. High availability is a very big marketing message for these services. It's one of the things that the cloud is based on. However, with high profile, high public, high availability also comes some bad PR if you have problems out in that space. And there are significant outages in the cloud, very significant. In fact, let's just look at a couple very popular, big names in the last 3 months. In June, I'm sure some of you remember when Gmail went down, 5 million users lost access to their Gmail for a few hours. About 200,000 lost access for 4 days. Google admittedly had to restore from tape backup to actually get some of that Gmail data back. So the redundancy in their very large file system was not able to maintain some of that user's data. And so they restored from tape. In June as well, Amazon, one of the largest, if not the largest cloud provider globally, had some very serious issues when its Elastic Cloud, the EC2, and its Web Services Cloud went offline in the Virginia data center due to massive power outages on the East Coast. Some of your favorite things went down with it. Netflix, Pinterest, and Instagram all went offline. I'm sure you know about the statistics of how much bandwidth Netflix uses every night, after people get home from work. But on that day, they all went down with the Amazon cloud. Another one just last month, Salesforce, who is all about the cloud, no software, all in the cloud. They had a significant data center power glitch, and they claimed, quote, it was a fault in our storage tier, end quote. I'd be interested to know what the fault in their storage tier actually was that caused Salesforce's customers to go offline, who, of course, bank on the fact that their stuff is always available online. And just last month as well, a huge DNS outage for Zerigo. That was a denial of service attack that brought that down, and with DNS propagating problems, people couldn't get to websites, and a lot of online hosting providers could not serve their customers. That's in a period of 6 weeks for massive major outages. So as to cloud reliability, just like data storage device reliability, it works great most of the time, but when it doesn't, it gets ugly fast. To quote myself, or somebody in this case, I'm not sure, if something can go wrong, it likely will. That's the world we live in here at DriveSavers. So now that I've scared you a little bit, what about choosing a cloud provider? How do you safely and intelligently move forward into the cloud if you're not already there? And I'm sure many of you are there by default, by just enabling some services that came bundled with something you have, and maybe you're already using the cloud. But here's a checklist that you can use in considering what provider you want to choose. Of course, first you want to design and implement a recovery restore strategy. That is, you need to conceptualize what your ultimate goals are before you engage any particular partner, and you need to seek a solution that fits your needs specifically for your organization. There's a lot of cookie cutter solutions out there. Those are not necessarily appropriate or perfect for you. Do you require U.S. federal compliance in any way? Do you host medical data under HIPAA compliance or financial data or any type of data that has to subject itself to federal compliance and maintenance? If so, you may not be able to use some cloud services from restrictions. You should require encryption and understand the security protocols in place by that cloud provider. Super important. Of course, where the rubber hits the road, you've got to determine the real total cost of ownership for this service and weigh that against the risks of not doing it yourself. Know where your data is going. Unfortunately, not all data centers for cloud service providers are located, well, in the United States or in secure environments overseas. Ask specifically for documentation of where your data may live, in what data center, in what environment, under what regulation. Insist on an acceptable recovery window. That means how long can you live without your data? How long can your business survive without your customer information? Make sure you define what that exposure time is that's comfortable for you to survive. And seek out other client opinions and reviews. And I don't mean just checking review sites. I mean actually talking to customers who are using those cloud providers directly. And with any contractual obligation, of course, read the fine print. Free accounts are free for a reason. They don't come with much of a service level agreement. And if you are paying for an account, that's great. You do get some additional coverage. Know what the coverage is. And ultimately, and most importantly, ask the hardest question you can ask the salesperson at that cloud provider. What happens when you go out of business? Where does my data go? How do I get it back? And how do I know that it's safe? Because unfortunately, the industry has shown us that these companies have been going out of business, not quite as often as they are opening up, and that's good news, but nonetheless, some of them do go dark, and when they do go dark, your data could go with it. So let's talk about data centers, or DC's storage technology for a moment, and get back to some of the stuff we're dealing with on our regular day here around DriveSavers. When you think of a data center, think of a very, very, very large facility, probably with not too many humans working in it, storing a lot of servers on a lot of storage with a lot of data. Typically, these are secured multi-location distributed file systems with lots of data redundancy, redundant power connections and providers. These facilities are using high-capacity enterprise SATA and SAS hard drives in big storage arrays and solid-state drives in blades and servers, more and more today than yesterday for sure. They're also using large, very significant tape backup libraries like Commvaults and other devices, or they're doing disk-to-disk backup. And virtualization is everywhere in the data center. I mentioned VMworld earlier. Of course, there's Zen in the open source. There's Hyper-V from Microsoft. The concept of virtualization, just very quickly, of course, is using high-powered hardware on which you can run multiple operating systems, file systems, virtual servers, and environments in order to consolidate your assets onto really good performing equipment. That's great, but the analogy of the more eggs in one basket, the bigger the omelet when it breaks, also works here, because in an environment where there are many virtual machines running on one piece of storage hardware, if that storage hardware goes down, so do all the virtual machines and all the data with it. So what about new data center technology? Data centers have been popping up all over the place, and in the news you usually hear just about how much energy they're using, unfortunately, because they do consume a lot of juice. Well, there's a high-profile site recently that Apple built in North Carolina, and it's, well, the word green is being thrown around all over the place and talking about it, even though Greenpeace says that Apple's still not green enough in their new data center. They're now using efficient solar power and hydrogen cell power to supplement the grid power that they're utilizing. And rumor has it they're going to duplicate this data center again somewhere else. So with all the storage technology inside, there's also new data storage technology and power management technology being used in these new data centers as they deploy all around the world. So what about inside there? What are we seeing inside of a data center? Well, what we're seeing now, of course, are solid-state drives appearing en masse in cloud services. Why are we seeing SSD, a product that costs a significant amount to purchase with a lower capacity, showing up in these massive facilities? Well, SSD provides huge advantages in speed and reliability over traditional hard disk drive deployments, especially in transactional and high input-output need environments. Let me be clear, though, that solid-state drive is not replacing large capacity hard disk drive. Remember that Seagate has said they will have a 60 terabyte hard drive shipping in about 4 years. Hard drives are not going away. Solid-state drives are complementing them. If you need petabytes of storage, you need to be running lots of big hard disks. What we're seeing now are tiered solutions. That's solid-state drives and hard disk drives living heterogeneously in the same environment with RAID and storage area networks. We're seeing these appear in the data centers today, and all enterprise and mid-range storage companies are now selling these devices into the public. Of course, we're seeing the growth of PCIe solid-state drives from many OEMs. Think of companies like Fusion IO, Intel, OCZ, OWC, SanDisk. All of them are now making a PCI-based SSD solution, which can replace an entire rack of hard drives in a data center with a single card. And there are now specific cloud-based solid-state drives now shipping. Here's one case in point. SandForce, acquired by LSI, since I think we last spoke to you, is now shipping the SF2481 Controller. That controller is optimized specifically for cloud computing environments. And remember that DriveSavers is the only SandForce LSI trusted data recovery partner. This is a big deal because SandForce now has more than 25% of the SSD market controlled and over 50 brands running their controllers like Kingston, OCZ, OWC, Intel, SuperTalent, and DriveSavers is the only company who can properly service any of those SSDs. Really neat stuff is going on with these new controllers to support the always uptime of cloud environments. New controllers have predictive failure analysis firmware to help ensure reliability. They have double AES encryption equal to over 300-bit protection. These are very complex devices, and I sure hope we never have to see one in the lab for data recovery. But these are some of the drives that are controlling some of those solid-state solutions in the data center today, and we'll see more specific applications coming as this market grows. So why data recovery? With all this new backup technology, all these cloud providers, why do we still need to be in business 24 hours a day saving data for customers? Well, it's simple. Hardware breaks, people make mistakes, and Mother Nature is harsh, as she is being right now, once again, bearing down on New Orleans and memories of Katrina and other disasters in our minds, while fires are burning in California. The reality is, when you least expect it, expect the worst, because that's when it's going to come and bite you. That is why data recovery is still necessary, even when talking about all this great technology. So in summary, and we'll be running out about 30 minutes here into the webinar, cloud backup is a good partial solution, but not the only one. Okay? Do your homework when choosing your secured cloud provider. Remember, at a minimum, the 3-2-1 concept for data backup. At a minimum, 3 copies of the data on at least 2 different devices with at least 1 offsite location. And I would say complement all of that with your cloud provider in addition to the 3-2-1 concept. And that might be just about enough. And lastly, and of course always, call DriveSavers if you need help anytime, day or night. We are always available to help you with any type of a data loss scenario. And that concludes this portion of the webinar of data recovery from the cloud at 20,000 feet. Thank you so much for your attention during that. I hope you got a brain full of good information, and some of it you will retain. And John Christopher is going to help moderate a little Q&A if we've got some questions, and then we're going to do a little bit of a giveaway as well.
Indeed. So if you could please use the questions panel to place your questions, and I will read these aloud. And it looks like we have a question, the first one here, regarding the iCloud hack. How is Apple not providing versioned backups?
Oh, that's an excellent question. Oh, that's an excellent question. In the case that we discussed with Matt Honan, I am not so sure he was fully utilizing what was available in iCloud for space for his backup. And I am assuming you're referring to versioned histories as Time Machine can keep locally attached, and as I think Dolly Drive does online, if I'm not mistaken, supporting their Time Machine in the cloud solution. So check into that. I can't quote specifically for Dolly Drive, but I believe they allow versioning in backup because they're using Time Machine's technology via the cloud. As to Apple and versioning with iCloud backup, I actually don't have a great answer for you on that. That'd be a good one to direct to them. But I'll take that one on the side and dig a little deeper to make sure we've got full knowledge on what's going on there. But excellent question.
Okay. Once again, if you have questions for us, please enter them into the questions panel. I will read them aloud, and then Chris will respond. Another question. Actually, it looks like it's a continuation. He says, regarding the iCloud hack, how is Apple not providing versioned backups for Dropbox?
Excellent. With Dropbox, I assume you're referring to Dropbox, the company, not Apple's new implementation of its own iCloud box. Dropbox is actually, I see, being bundled with a couple of the other personal cloud services out there. I believe Western Digital's personal cloud product has integration with Dropbox built into it. And Dropbox is an excellent solution. It's not inclusive for everybody, but it is nice and portable across devices, obviously with iOS integration included there. Same is true, though. It's a Dropbox. It's not a versioning history tool, but by concept was a simple place to drop your stuff. I don't know if that'll be a disadvantage later as they try to grow that business model, but it's kind of a one-size-fits-all, throw your stuff in the box technology right now.
Our visitor has a comment. He says, actually, sorry, I meant to clarify my first question that Dropbox does actually provide versioning. I've used this to great success.
Okay. Well, thank you for that point and for that clarification. I am not utilizing Dropbox in that method, but obviously I need to look at that. So thanks for your clarification on that question in the comment.
All right, let's go to our next question, which is how difficult is data recovery from SSD versus your typical HDD?
That is an excellent question. That is an excellent question, and it's one we covered quite in depth in one of our prior webinars. But in a nutshell, solid-state drive uses a completely different physical layer technology to store data. We're dealing with cellular data storage, pushing electrons across a floating gate in order to trap them and read bits on solid-state chip-based technology. In contrast, hard drives are obviously using magnetic storage to encode bits onto magnetic surfaces and read them back. In data recovery, when dealing with chip-based solid-state technology, there are really two main points of failure in data recovery. One is either the controller itself or the firmware which is loaded onto it, or a failure of the NAND flash, the actual media itself. One of the largest challenges and differences in SSD data recovery today versus hard disk drive is that there is encryption in place in most SSDs shipping today, as well as other exotic technologies in the controller like deduplication, compression, and a few other tricky things that make it imperative that the controller survive on the SSD in order to recover the data. On a hard disk drive, we have far more options in the repair and recovery of a device, primarily because it's an electromechanical device, and the main points of failure there are the head-to-disk interface or one of the components. So in an SSD, we have very few components that we can replace and very few that we can modify. On a hard disk drive, we can replace almost everything, including transferring platters from one device to another with fewer encryption challenges. All of that being said, the recoverability of SSD continues to increase as we increase our technological toolbox in our research and development team, and as we align closer with more of the NAND flash manufacturers and SSD controller companies. We've already done that dance with the hard drive companies for many years now, and our expertise and toolbox is quite large there. So thank you for your question, and it is an ongoing and morphing process as to the recovery of SSD, and check back with us in the future if you have more questions on that.
Okay, here's a question that is simply, oh, here we go. Okay, what does DriveSavers use for the cloud and or backup?
Ooh, that's an excellent question. Ooh, that's an excellent question. As many of the things here at DriveSavers are concerned with security, so is the information that we share about how we do things. We are huge advocates and fans of controlling one's technology and insourcing rather than outsourcing it. We typically don't name or endorse in the public what we are doing, so I won't really be able to answer your question in full by any means there. But the second part of that question was, let's see, not only what do we use, but for backup. That's an excellent question for backup. Well, internally, we process, if I am not mistaken, a little bit shy of a petabyte of data every month or so. So with that massive amount of storage internally within the facility, as I said, we control our own assets. We actually build many of our own servers, and we are using some high-level commercial equipment as well. But if you've ever been on a tour of DriveSavers, you may have seen some of the things we're doing internally. Needless to say, we have many layers of redundancy and security and backup in place, but that's about the entirety in which I can answer that question.
Okay, in terms of cost, what would be the cost for data recovery for solid state versus your standard hard drive? Excellent question.
Okay. Excellent question. So pricing and costs recovery on SSD versus HDD. Although in the marketplace, obviously, solid state drives cost more per gigabyte or per terabyte than hard drives at a ratio of about 8 or 10 to 1, that is not true in the data recovery laboratory. The pricing for SSD is actually equivalent to hard drive pricing at DriveSavers. We chose to do that very intentionally because we knew that early adopters in the industry were going to need data recovery, and we didn't want them to be surprised by looking at a price tag that was 10 times the cost of hard disk drive recovery. Internally, we spend a lot of time, money, and resources on research and development with SSD so that we can maximize the opportunity for recovery while keeping the cost down for the user. And even though most users, just like you asking the question, have an assumption that we charge more for data recovery from SSD, currently our pricing models are the same. And if you have any specific questions about a device, call our 800 number anytime, and we can provide you with up-to-the-minute pricing estimates.